So what we are going to be doing today, guys, is we're going to have to take a first derivative and then we're going to have to take a second derivative. Okay, so what the second derivative tells us is it tells us the concavity of a graph. Okay, and what we're going to be able to do is we're going to start being able to find inflection points. So when I talk about concavity, do you guys know what I'm talking about? Whether it opens up or down, like in a parabola, right? Like you guys were able to tell because of the a value in a quadratic, if it was positive, it opens up. If it was negative, it opens down. Okay? So that's exactly where this comes from, too. The second derivative, if it's positive, it's opening up. If it's negative, it's concave down. Now, we have to remember, if something has a greater exponent than 2, it can change concavity, and what we call that is an inflection point. Okay, so we're going to focus on finding that. First example I'm going to give you guys is going to be a quartic function. Okay, it's just a power or a function to the fourth power. So here we go. Example 1, we have f of x equals x to the fourth minus 4x cubed. Now, we're going to go ahead, we're going to find the first derivative, which I don't think will be a problem for us. Inflection point. So as I'm finding this first derivative, okay, we're just going to use the power rule. So, what?
4x cubed minus 12x squared.
Yeah, 4x cubed minus 12x squared. Now, this would tell us if a function was doing what, according to the first derivative test? Increasing or decreasing, and this first derivative helps us determine maximums or minimums. That's what I'm looking for. Like if it's increasing and then it decreases, hopefully that's a maximum, and then vice versa. Okay? So we can't stop here today. We have to take a second derivative. So let's go ahead and do that if you haven't already. So f double prime of x is equal to, I'm going to go ahead and just use the power rule again. Here I'm going to get 12x squared minus 24x. Okay. So, very similar to what we just did last time with the first derivative test, we're going to take our second derivative and set it equal to 0. Now, this is what Kaylani asked before, says means what we are looking for is we are looking for inflection points. When we set it equal to 0, we're saying, okay, I want to find the inflection points. Okay. But before I attempt to find inflection points, what you guys will notice is you want to factor this. Is there anything that factors out of both of those terms? 12x, exactly. So 0 is equal to 12x times x minus 2. Which means if I took both of those individually, I set them equal to 0, you would find x is equal to positive 2 and also 0. Okay? So what this means is we are finding these are inflection points, hopefully. So you'll see. So what we're going to do is we're going to chart it, and these are possible inflection points. So what that means is it could be changing from concave up to concave down or vice versa. Okay? So what this means is what we're looking for, if you guys don't know what an inflection point is, so like let's just take, I'm just going to draw a random graph here. This is what I'm talking about. The inflection point just in this random graph is right here. See how it's changing from like concave down because it's opening down to something that's opening up. That's an inflection point. Okay? This is what these could be. Okay? All right. So let's, like I said, we're going to go ahead